Hello all, welcome back. So today we are going to start our class with dependent sources. So before we start, so happy Diwali to everyone. So to start with, as you can see, today we are going to discuss the dependent sources. How we are going to use the dependent sources for our simulation. So I hope the questions are visible. So let me slightly increase the size so that it is more clear to you. So to start with dependent sources, so we have here different types of dependent sources. This is current source, which is dependent on voltage Vx. So this is voltage dependent current source. Then next one is voltage dependent voltage source. This is voltage dependent current source. And last one is current dependent current source. So to represent the dependent sources, we have PSPICE software. We represent it by E. So this is voltage dependent voltage source. Now here, as you can see here, this round shape or this symbol of the source represents the source side, and the other side is the dependency side. So whenever we see this circle, that is the source, and remaining side is our dependency. So this is voltage dependent voltage source. Then let's see the next one, which is F. Okay, we can let us put this in the circuit itself. So this is E. Then next is, let's check F. So this is F, which is current dependent current source. Then next is G. So this is G. G is voltage dependent current source. And finally we have EFG. Then next is H. So H is current dependent voltage source. Okay, so now let's see how we can use this in our circuit. So for placing it anywhere in the circuit, as we have discussed in our earlier class, so we have to either rotate them or flip them. So for rotating, we can press Ctrl and R, and if you want to flip them, so for flipping we have to use Ctrl F. So it will flip the components. Okay, so now let us make our circuit. Let us consider the first circuit. So to draw the circuit, we require 4 resistors. So we can directly get it from here, 4 resistors. And we require one current source. The current source is IDC. Yes, this one resistance is left, so this will come here. Yes, now let us join the circuit. First I am connecting the circuit without the dependent source, then we'll put it accordingly wherever it is required. As we have discussed, whenever we have three branches, we have a node. Next we require a ground, so grounding is also done. Now let us put the values. This is 15 ampere. As we have discussed, by double clicking the components we can get the values. This is 1 ohm, so I can directly put it as 1. Next is 2 ohm, so this is 2. Then this is 2 ohm. Then this is 1 ohm. So I guess all the components are named. Yes, middle one is 3 ohm. So this is 3. Okay, so now let us put the dependent source. So we have a voltage dependent current source here. So out of this EFGH, voltage dependent current source. So current source we have this two, right? So this is current dependent current source, this is voltage dependent current source. So we are going to put this one. So the direction of the current source is on the top, so let us put it on the, rotate it. Okay, sorry, it got connected, so let me put it here. Yes, now we can connect it over here, right? Now see, this connection should not be there, so let us remove this. So this current source is pointing upward, so it is also pointing upward. So this is done. Next, what we have to do, where is the dependency? Dependency is over Vx. Where is Vx? Vx is on this 3 ohm resistor. So that means, let me put this 3 here. You can do that. We are just shifting the position, not changing the values. So next is, this should be Vx. For Vx, positive terminal should go on right hand side, negative terminal should go on the left hand side. So that will be easy, because just connect them with the dependency side, and that's it. It is done, right? As you can see here, this is the source pointing upward, and dependency is Vx. So Vx positive terminal is connected here, and negative terminal is connected here. So we know voltage we have to connect in parallel, so we have connected it in parallel. Now one more point that is left, which is the multiplication factor, which is 1 by 9. That means the gain is 1 by 9. So how to put the gain here? That is not done yet, right? So initially, whenever we do not put anything, the gain is considered to be 1. So if you want to change that value, we have to double click here and then change this gain. As you can see here, this is the gain. Gain is 1, so we have to make it 1 by 9. So 1 by 9, you can put it like this, or it will be best if we divide it and then put the value 1 divided by 9. So let us take the calculator. So what is the value? So let us check. 1 divided by 9 is 0.11. So we can put here 0.11. Okay, I can put one more value. Okay, so the gain is 0.11. See, correct? So now we have to run this. So before running, we cannot put any component which is not used. So let us remove this. Okay, now save the circuit. So for saving the circuit, as we have discussed earlier, so this is our dependent source. Okay, DEP, dependent source, suppose circuit number 1, and today's date is 21/10/2025. okay, so saving is done. Now what do we require? What is asked in the question is determine current I1, I2, I3. So we'll, okay, let's run the simulation and see what is the answer. So the current we are getting here is 15 ampere, 7 ampere and 9 ampere, and if we match with our answer, oh, there is a surprise. So the answers are different. So let's see which one is feasible. So since we are having all the branch current, so let us verify here in the simulation itself. So this is 15 ampere, it is obvious this will be 15 ampere. Next is 8 ampere and 7 ampere, and that is also correct. Is 15 ampere is getting divided into 8 and 7, and when we are receiving it, we are having 6 ampere and 9 ampere, so addition of 6 and 9 is also 50, so that is correct. Then again, if you see at this point, we have 7 and 2 will be 9, so that is also correct. And then again 6 and 2 combination is also 8, so this answers, the simulation answer seems to be correct. And here if you see it in the solution, that is provided as 15, 11 and 17. So 17 is quite confusing, because the current cannot increase to such a higher extent. So let us consider whatever we are given here in the answer, that is not correct. So the correct answer will be 15 ampere, 7 ampere and 9 ampere. So this is the solution of the first numerical. So let's go to the second numerical, generate another simulation. So this is our circuit diagram. So now we'll see one more way of generating the circuits or drawing the circuits, that is, we'll first draw the connections and then we'll put the components. So these are our connections, and let us put the components. Resistors we have 3 here, so 1 2 3. Then we have IDC, so control R. Then we have sources, so we have voltage dependent voltage source, which is given by E, and also we have voltage dependent current source, so that is given by G. So the direction is visible here, so let us put it as required. So there is the direction, then supply direction is also correct, so let us put it here, and then we require the grounding. Okay, so now our circuit is done. Now let us put the values. This is 20, then next is also 20, then this is 50, and current source is 5 ampere. Okay, and the gain are, this gain is 0.4, save attribute. Okay, then next this one is gain is given as 0.01, so save attribute. Okay, so the gains are given, the values are put. Okay, so now next is what about this? So in every component we can see there is a extra line, so to remove that extra line, just select that line and delete. So in this way we do not have to draw one by one points, so we can directly first make all the circuit connections, then we put the components. So now our circuit is we have eliminated all the extra lines. Now next is connecting the dependency. So first one is 0.4 V1, so V1 is this one, voltage across 5 ampere. So upper terminal is positive, lower terminal is negative, so we can directly put it like this. Then lower terminal is negative, so this is done. Next is current source is having also V1, so let's put that V1. So this point will go to the upper terminal, and second point, let us put it from this side, it will go to the lower terminal. Okay, so this connection is also done. So now let us save and run. So let us consider this is our second circuit, so second, save. I hope now everything is correct. Now we require voltage. Yes, so the answer should be 140 volt, and we are getting 140 volt here. So this voltage is coming across this line, that this is connected to the positive terminal, so we are getting 140 volt across the power supply. That means the voltage generated at this point will be 140 volt. So our answer is also matching now. So now let's go for the third circuit. Similarly we can make, so you just observe. So let's first take another file and start our circuit. Okay, now let's put the dependent source. So this is current dependent current source. Now till now whatever we have discussed, all are having voltage dependency. Now we are having a current dependent source. So let's see. So this is done. Now here in earlier cases whatever we have did till now contains all are voltage dependent, so we are putting everything in parallel, right? So but in this case we have to put this connection to be in series because we require current dependency now. So this should be in this branch. So let us first open circuit this one because we are putting it here. So let me put it like this. So now we have to put the connection here. That means whenever current is flowing from 2 ampere, it is reaching here, and then from this point it should go to the dependent source, and then from the dependent source it should reach here. So as we can see, the direction is from this to this. That means this point will be connected to the upper terminal. That means we have to connect this point to the see. This problem we might face, that we should not have any node here, but we are reaching to a node at this point. So let's see how to eliminate that. Let us try in another way. Still we are having this node, so I hope if we try it from this direction, that should not come. Let's see. Yes. So whenever we are just crossing this resistor to that first point, that is why we are getting that node, because the system is considering that this resistor should also be connected. But if you are putting it slightly further away, then the connection is not getting aligned. So like this, so the current will come here, it will move to the dependent source. Now next point will be coming here. So let's see, let us put this point from here till here. So now also this is properly connected. So see here, from this point it is moving inside the dependent source and going out, and it is reaching to the 10 ohm resistor. So this is also correct. Now put the gain is 1.5. so I guess our circuit is done. We have let me check again, 2 ampere, 10 ohm, 20 ohm, 25 ohm, we have 5 ampere, we have 5 ohm here, and this is 1.5 dependent source. Yes, so everything is correct. So let us save and run this. So this is our third file. So this is 3. So now we have to determine the current this time. So let's execute the current. So how much we are getting? We are getting the current as, we require current across Ix, means this current. So this current is coming as 8.33, and that is the answer given. So this is how we can solve circuits, or we can simulate the circuits which contain dependent sources. So I guess everyone have learned whatever we are discussing today. So I hope now you will be able to solve any circuit or simulate any circuit which contains a dependent source. So along with this, now I would like to again put another discussion for today. So let me check the first file. So okay, this is our first file. I guess I have kept all the circuits here. So this can also be possible. We can solve all the circuits together. That can also be done. So in one simulation, if they are interlinked, or suppose we want to discuss everything together in one file, that can also be done. So if we run the simulation, get the voltages 140 volt, that is done. Then current 15, 7, 9, and this is 8.33, that is also done. so everything is coming. Now this simulation, what we can do is, now let us see how we can make this simulation an attractive one, or how we can give some styles to this platform. So to do that, we can take help of this draw, and we can have here, as you can see here, we have arc, circle, box, and polyline, text, right? So we can use this. So let us draw a box containing all the circuits. Then we can put yes, another box which will be here, and then we can also put another box to separate the circuits. And then we can also put another box. Okay, I guess this line should also work. Yes. So now this is, all the boxes get separated. Now let's see what else we can do here. So we can put text also. So let us consider title. So title is suppose circuits with dependent sources. So this is our, suppose, our title. So we want to put it here. So our title is done. Next, suppose we are going to put about our names and roll numbers. So that can also be done. Suppose name, I am putting my name here. So this is done. Then suppose roll number, again we can put text, or we can also put a text box. That can also be done. See, we can directly put more contents instead of putting everything in text. Suppose roll number 2, 3, 4, 5, 6, some roll numbers, whatever you may be having. So like this, you can also put your section here, right? So we can put section here also. So let's see, suppose section B. So this content is here. Yes, it will come as appear as a box because we are asking for text box. So that is where we are getting a text box. So the difference between text and text box, I hope you have understood this. Okay, suppose let us consider we want to put names of our circuit. So that can also be done using this text box. So instead of taking the text box from here, we can also press Ctrl and T, and this will appear. So let us consider circuit 1. So this is our circuit 1, and we can put it multiple. Okay, there is less space, so I will suppose put it here. Later on I will shift it to the suppose let us get some space, so we can shift it from here to here. And then this is circuit 2. Okay, so now we are having everything as per our requirement, right? So you can make it as per your requirement. You can put more number of boxes. If you want to put it in some other style, that can also be done. Suppose you want to put it like this, so that can also be done. You want to put it here, you put the names here. So like this you can modify as per your wish. Okay, and this is suppose like this. So that is also done. This is suppose I will want it here. So that is also putting another style. So I hope you have understood how to do or how to solve for dependent sources, and how to make your your customized your designs, putting your names or putting titles or everything, every details in every circuit. And suppose we want to do the simulation, it will also work. Wherever we require voltage, and can calculate the voltage, put the voltage or determine the voltage or display the voltages, and also as per our requirement we can also put down the current. So now this whole thing for if you want to put it in left file, if you are making a left file out of this, then you can directly take screenshot from this one and then put it in your left file, and that's it. So this is how we can solve for dependent sources. So I hope you have understood. So we have considered both voltage dependency and current dependency as examples. We have also seen voltage source and current source, right? So I hope you have understood and you will be able to solve different circuits containing this type of numericals. So thank you for joining. So we'll be joining soon, and then in the next class we'll be discussing about different theorems, and in different theorems we'll be considering one circuit containing only independent sources and next one circuit containing dependent sources, and we'll prove without using the theorem whatever we are getting, and with the theorem whatever we will be getting, both should be same, right? So we'll be verifying that. So thank you for joining. We will soon meet again in the next class.